The time was in the middle 80s, and I was working with Steel Incorporated. I was what they call the field applications manager. I worked a lot with a product tester like Tom Trebby, and my supervisor was Roger Simons. He headed up the technical services division at Steel Incorporated. Probably 85 to 87, something like that. He asked me to go out to the Mount Shasta area country. You can, from either one of those locations, see Mount Shasta, which is about 14,000 feet or so in elevation. The dealer there had connections with Weyerhaeuser, and we went out to the local shop there at Weyerhaeuser, where they did most of their service on the saws and other equipment. The guys, and there was probably about 50 of them, I guess, on the one crew that I met. And I think his name was Cliff at the shop. He was responsible for keeping all the saws maintained and the saws sharp and cleaned. Well, the guys get on a school bus, basically, a big bus, and went up to the mountain pretty much every day. What I was out there for was to discuss with the dealer and the shop there about filters that were needed changing, basically because just 2 or 3 years prior to that, but there was still a lot of it in the woods, was what we call Mount St. Helens dust. It was come from the volcanic eruption of Mount St. Helens, very early 80s. The guys were still having to deal with it up on the mountains and in the woods. And what had happened is this stuff was just a very fine dust that would work its way through the filter systems and would polish the pistons and polish the insides of the crankcases on these saws and caused a lot of wear. So Roger was trying to come up with a filter system, kind of working, I think, in conjunction with K&N to see what would work. He knew that most of the loggers out in the area used a foam element, and that sometimes worked pretty well against the Mount St. Helens dust, but the volcanic ash, but more or less it collected water. And in that area of the country, there's a lot of moisture most of the year, and so what would happen is the moisture would make it through and absorb into the foam element, and then more or less would make it to the intake side of the piston where it would cause abrasion. So that's kind of what I was talking over the shops with. I found out quite a lot there at the Weyerhaeuser shop that I started using in service schools and also out and about with the professional operators. And that being an understanding of a system that they had there at the shop for rotation. You see, every day they would take, and the operators would go up to the mountain with their power head and a bar that had been dressed and cleaned, and 3 chain loops. Those chain loops had been sharpened by Cliff there at the shop on kind of a third shift. They had a Ziegelmeyer square ground machine, and also a depth gauge machine that he had developed. Len Ziegelmeyer was quite an engineer and hand-built and designed these sharpening systems. They were pretty much automatic once you set it up. He had pneumatic controls and things on them. There at the shop at Klamath, they would set the chains on there and adjust to what he wanted and then rotate them through. He went through somewhere around about 150 chains every day or every other day. And the guys always had sharp chains. They didn't do any sharpening in the field. They more or less brought that rotation of a bar and 3 saw chains back to Cliff every night. They went on to the machine, and by next morning they were ready to head back up the mountain. But what they found out was, and what I found out too, putting that type of process into some other operations, really evened out the wear on some things that way. They always had sharp chain to work with for production and safety. One thing they did, they put the chains into a piece of old fire hose. They had 3 sections of fire hose. They would squeeze the edges of that flat fire hose, drop the chain down in there. They could even put some bar lube down in there to keep the moisture out and to keep the chains lubricated. And then they had a length of starter cord that tied those three pieces of fire hose together. And that was a system that they had for a spare starter rope in case they needed it up the mountain. And then they would pull out the sharpened chains, put the dull ones back in there. Cliff had them marked with numbers and coded so he knew what went with what. But it really didn't matter. The guys always had a sharp chain when they went back up the hill, and also a dressed bar. So they would drop that bar off and the three chains in the evening. They would pick up another bar and three sharpened chains the next morning, and it always worked great. And what he would do is, as they would get worn, they would rotate new chains into the system. Well, I asked him where he come up with that. And more or less, he said an old operator's manual, and I think it was from Homelight back in the days, that basically showed a rotation system. It had a rotation picture that showed a combination of 4 chains that would run on 2 sprockets and then 1 bar. And that, more or less, as you made it through that life cycle, the 4 chains and the 2 sprockets would last for the life of that bar, and you just kept rotating in the new parts. And so it evened out the wear, and what they found out was they picked up life of the chain loops for sure too. Well, I took that basic same system and put it into an organization for Union Camp out of Chapman, Alabama called Rocky Creek Logging. And we found out we picked up 1 full rotation of a saw chain, and basically we increased the life of the bars by something like 70%. And it really ran so much smoother too, because they always had a good sprocket that was in the system. So that was something that picked up out west and brought to the east. Then we also got the filters going on that particular project. I started seeing them putting on the test units in the south, and we ended up with a filter rotation system also. The guys would come back in with the units, dirty filters would go off. They went into an agitating parts cleaner that would, soap and water, basically wash them. They were then blown out and dried and ready to go back on the saws. And we found out that really increased the life and the airflow of the chainsaws and the filters. And so that combination really worked good, and very, very similar to what they had going on at Weyerhaeuser, cleaning out those foam elements. Well, when the HD filter for steel came out, it really made a big difference in the life of the engines out there, and it gave a pre-filter that could be cleaned, and then also a washable filter that could be washed and dried and put back on the units. So that worked great. Another thing that we were working on out there, and this was something where on the eastern United States, the larger saws and lower elevations would end up with sometimes some piston and cylinder problems because of lean operation. And so on those bigger saws, they put a fixed jet carburetor system that was set up with a certain size orifice for the nozzle. And so that would be where there was no adjustment to the high-speed screw. You just left it closed the whole time, and those nozzles would supply the amount of fuel that was needed, so they didn't have a lean run situation in the saw. And so that created a problem for the West Coast also, especially on the higher elevations, because as you get up to 7,000 to 14,000 feet or so, the air gets very thin. And so if you can't lean out the carburetor, you end up with a saw that won't run. In other words, it's so rich that it can't produce any power. Matter of fact, we always used to talk about that reason why the guys really need the bigger saws was not necessarily for long bars. It was because there was no replacement for displacement. You had to have a cubic inch volume of air going in and out of that saw to mix with a little bit of fuel to keep the proper 14.7 to 1 fuel to air ratio going, so you had enough power to pull the saw. If you took a smaller saw, say 3 cubic inch out there at those high elevations, you had no power whatsoever. So sometimes even a 4.5 or a 5 cubic inch chainsaw would have only the power of probably a 3 to 3.5 cubic inch chainsaw here in the east at lower elevations. So it's quite interesting learning those things. There was a lot of testing and trials that was done. A lot of the dealers out that way were very mechanical and helped in organizing a lot of the tests and the updated systems that was put into that. That was a great time. I wanted to pass that along to you about the rotation systems and how they work. If you haven't thought about it, it's a pretty good way to be able to reduce your cost, maintain your safety, really get performance out of your chainsaws. So I hope you pick up something from this little Tim's Tips and apply it to your work in the future. We hope to see you along the Forest Apps Road. And this is Tim Ard wishing you good sawing.